Hi, welcome to Fortnite Power Videos. This is DC here. This is the part 4 on Mifare application directory. And in this video, I'm going to show you how to create a matte formatted Mifare classic step by step. And before I do that, I'm going to recapture some of the fundamentals or the basics we have discussed in all my previous videos. So we have been referring through one of the document from NXP called Mifare application directory. So this is the summary of the entire document. So the document speaks about the matte structure, the matte sector, the very first sector of the tag. Speaks about the default key, which is this is also called as a public key, which is A0 to A5. And we know there are application IDs, and each ID consisting of two parts, the cluster code and the application code. The cluster code defines the category or the kind of the application. For example, whether it is a transport type of card, whether it's a skiing card, whether it's a like a library card. So there's so many categories which is also defined if you go to the end of the document, the matte document for NXP. And we know that the cluster code is 1 byte, and this is the most significant byte of the application ID. And every application also got its own ID, so this is unique to the application. These are some of the predefined application IDs that belong to the category called administration. These are kind of like a reserved application IDs. If both are 00, it means the sector is free. If it's 0001, it's a defective sector, and reserved sector at the additional directory and the card holder information. Now you need to know all these things only if you want to adhere to these standards. Say for example, I can have application ID with 0004 and keep the information about the card holder, the name of the person, his address, age, and so on. Through the documentation, there is a mention about key B, and it's also said that key B must be kept secret, whereas key A is known to the public. So any changes to make, any changes you want to do for the sectors has to be done using the key B. And in order to achieve this, you must have the correct access rights or access bytes for each sectors. And the documentation also says the unused sectors must have a different or unique key B. Say for example, if I have got that Mifare Classic has got 16 sectors. Assume that we have used only 3 sectors. The remaining 13 sectors which are not used, the document recommends to have a different key base. So you'll have 13 different value for the key B. And we also know about the CRC and information bytes. So throughout my last video series, I've been using this document, Mifare application directory, and if you scroll to the end of the document, you can see some of the predefined cluster codes. There is one more document which is called the Mifare Classic as a NFC type tag. Now this document speaks about how to store NDF messages. So we have got 2 documents here. This document speaks about speaks only about the matte structure. It doesn't speak anything about NDF or NFC. Whereas this document speaks about how to create NDF messages using the matte structure. So these 2 documents are very important if you want to understand how to create NFC type of cards using Mifare Classic. And we already seen few examples using the GoToTags software that uses the concept from both this documentation. So if you are a developer or a student of technology, I would advise you to have a copy of these 2 documents and keep reading again until you understand this concept. So the main object of this video is to show you how to make your own mat formatted tags. So these are some of the things we are going to do. Now, as I mentioned just now, there are two concepts here: the mat concept and NFC concept. These two concepts have got two different documents which I showed you. So we're going to write application IDs, we're going to write the information byte, we're going to compute the CRC, we're going to set the default value for key A for all the sectors, that is A0 to A5. We're going to have a separate key B values for all the sectors. We're going to set the access rights as 4 and 3 for all data blocks, and the sector block as sector trailer as 3, and we're going to set the GPB as C1. I mentioned what exactly C1 in my previous documentation. Sorry, in my previous video. C1 means it says the tag consists of a mat sector and whether it's a mono application or a multi application. And I'm also going to show you some shortcuts where you can load the data from a file and write to the entire tag. So this will be useful if you want to create plenty of tags of a similar kind. Now I've connected my A722 reader writer and I'm using the software A722 Made Easy version 2.7. So I'm going to use a brand new Mifare classic tag. So to make sure it's brand new, if you go and hit the read entire tag, if you're able to read, sorry, before that you had activated, okay, read entire tag, and all these sectors are read using the default case. So we are going to prepare the mat 0 or sector 0, and to do that we are going to follow steps. The very most important thing here is the value of key A. So the key A value must be A0. You can in fact you can authenticate this and keep it ready for writing. The key is the key A value of the mat sector is A0, A1, A2, A3, A4, A5, and the value of this GPB is C1. It's already C1, and I want the value of key B to be all FFs. I'm going to use all FFs for the time being, because so that we are going to use the goto tag software to use this to test this what we do. And I know that the access rights must be 4 for all the data blocks and 3 for, okay, now all the things we are doing here is just done within the software. We are just modifying the content of this grid. We are not writing to the tag yet. So we are ready with the sector trailer. It's ready now. We have got everything. The access rights also ready. The next thing is we need to have, this is the CRC, which you can do only after you complete these steps. This is the information byte. Now I'm going to have the information byte as 01, and I'm going to store so for example I'm just going to keep 01 for the time being, or we'll keep it 01. Now this is my first NFC sector, which is 03 and E1. This we have seen in my previous videos when you format the tag with the goto tag software. So I just need the sector 1. Now sector 1 corresponds to these 2 bytes. Now there is a space for 15 sectors. All the remaining, you have to think this as a UIDs, sorry, this as application IDs, and we have seen application ID 00 means there are free sectors. So with this I'm going to recompute the CRC. Just go and hit read mat 0. Everything from B0 to up to here is read here. Click on compute, you got C0. So I'm going to type C0. That's the CRC, and my sector 0 is ready. I'm going to use this the write sector feature, because I also want to write sector trailer. I'm going to tick this box and say you can probably clear this and you'll come to know all the sequence of commands that are used. Now in this write operation, the first block is not written because we know it's a manufacturer block, cannot be written. I'm going to prepare the sector 1, which is according to this the directory. The sector 1 is a NFC sector, and I'm going to have a empty endf message. So before doing that, I'm going to authenticate with the factory key, and we have seen in previous videos 0300 and FE. Now this is what you get when you format the tag using GoToTag software. So because this is an NFC sector, the public key of NFC sector is what's mentioned here. It's D3, it's F7, D3, F7, D3 and F7, okay. And also I'm going to keep the key B as all FFs. But if you remember the way this GoToTag software prepares the card, the access rights, you must have 3 here. By having a 3, if you go back to this list here, so 3 for sector trailer means the read or write is possible only using the key B authentication, whereas a 0 for the remaining data blocks means they are both read and writable using the factory setting. So if you want to know more about here, this is an empty endf message, and we did discuss about this in my previous videos. So everything here is a TLV block. So here the value for the tag is 03. 03 means it's a endf message, and length is set to 00. Because the length is 0, the value is not present. So the first 2 bytes says it's a empty endf, and the last one FE is a special tag to indicate it's like a terminator or the last TLV block. We're going to come back to this when I discuss in my future videos the second document I mentioned before. Now we are ready with this sector 1, and let me check in everything. Okay, so I'm going to write along with the sector trailer. So the write is successful. You can see all the commands that are gone here. So we have just written the MAD and the first NFC sector. Now I'm going to use the GoToTag software and see whether it will recognize our tag. So I've got this GoToTags Windows app running here. I'm going to place my empty tag. So you can see no records are on NFC tags. Looks like it has recognized a little bit. And if you look at these messages underneath, it says it did recognize that it's a formatted tag. And what I'm going to do is take this tag out. I'm going to write a simple URI bbc.co.uk/ okay, and I'm going to record this. It's saying place the tag. Okay, now we are able to write the endf message for this. So looks like whatever we did byte by byte, it's working all right with the GoToTag Windows. See, this GoToTag Windows, it's a very good software for students and software developers. So you can download this from the website, and it's very good for you to learn the structure of the various endf messages. Look at that. You can try so many things and look at the structure and the way it's written. Okay, I'm going to go back to the software and see what's written there. So back into this software, I'm going to bring the content of sector 0, sector 1, because we have not done anything for sector 2 and onwards. So I'm going to read sector 0, authenticate. Oh, sorry, I think something went wrong here. Authenticate, read, and I'm going to use the NFC public key, authenticate and read. Now here you can see that the URL what we wrote is stored here, and you can see it's a bbc.co.uk, and we still don't know the structure. So I know that this is a TLV block. Okay, so if you just go through this, the first 2 bytes, so T, L and V, 03 tag is a endf message, and this is number 14. So there are 14 bytes in the value, so you can count. There are up to from here to 14. You will have the value of this endf, and it is again terminated with the FE. FE is a special TLV, indicates the last TLV in this sequence. So what I'm going to do next is I'm going to use a sector 2 to store a different set of information. Now, so first thing is go back to sector 0, and in order to write, because of the access bytes access right set to 3, I have to first authenticate with the key B, and I know the key B is all of F's. Authenticate. Now you don't have to read because it's already there. I want to use the sector 2. So keep in mind the sector 1 corresponds to these 2 application IDs, and sector 2 corresponds to these 2. Now I'm going to use 02 and 00. Now if you look at the documentation, it said 0200 is the card. If you just scroll to that, let me check what it is. So I'm going to use, it's not you can say reserved, or probably now we'll try to use this one. So 0004, it's a sector containing the card holder information. Now you can just type in the ASCII for card holder information, or there is somewhere in the documentation tells you how to encode the name. You can have the first name, last name, and telephone, so on, but I'm going to just type in as text. So in order to use that, so I'll be using 0004. So the lower byte is 04. What basically I'm doing here is adding a new application ID. And keep in mind, whenever you make change for this match sector, you have to go and recompute the CRC. So probably later on I'm going to we're going to see what happens if the CRC is not right. So to recompute the CRC, let me check if it's right. Sorry, here we went wrong. It's 04 and is 00, and read the mat 0, recompute this, and this time it's going to be 88. Probably what you can also do at the same time, okay, let's finish this thing. Okay, now I've done that. So I've not modified sector trailer, I've not modified this, I just modified this block 0. I can just write this block 1. So block 1 is successful. Now let's bring the content of the sector 2. This is an unused sector, and we still haven't changed the keys. It's still a factor key. Authenticate and read. Got everything here. Now I'm going to autofill some text. This could be, say James Clark. You can type in whatever you want. End of the day, this is read by the software, which can understand the content of this sector. Say this could be, say, London. Okay, London. So I'm going to fill with space. Now if we want this to be red, we have to use a public key. I'm going to use the NFC sector public key, and I'm going to change the key to D3, F7, D3, F7, D3 and F7. Probably can keep the information same as this, 03. So change the access rights. This is going to be 3. So we have just prepared sector 2, and the sector 2 according to application ID is going to be the cardholder information. I'm going to transfer along with the sector trailer. I'm going to write, so the write is successful. Now it should work. We have done nothing. So let's go and see if the go to tag software to recognize this tag. Okay, if I place this here, now what has happened is it automatically tries to open the so this is a problem here because the URL is not right. So anyhow, this is the good thing about the go to tag software. So it automatically reads this endf message. It recognizes this as a URI and opens the browser with this URI. So our tag still works. However, you can't see the content of the sector 2 here. So next I'm going to show you a shortcut on how to create the entire tag, which is mat formatted and which also has got an empty endf message. So I'm going to place a brand new Mifare classic tags, and after the activation I'm going to choose this load file option. Now this opens up your Explorer, and I've got a file called mat.goto which I'm going to make it available for you to download. If I open, now this is the content of the entire tag when it's formatted using the go to tag software. Now everything is obvious. We have gone through this structure before in my earlier videos. So everything is ready now. Now the only thing what I have not done here is change the value of GPB, which is 40, but I want to keep it as FF. Now here the sector 0 is ready with its public keys and the key B, and all the remaining sectors are formatted as the NFC sector, because the corresponding application ID which is stored here, they say they are NFC form type with 0, 3 and E1. Even the CE is what the right mat is. So if you place because this is a brand new tag, I can just go and hit this write entire tag, and you can see that a series of 64 update binary command has been sent to write every block by block. It's 63 because the block 0 is not written in the software. So with this you can go and say whether it's able to get recognized using the go to tag software. Now I'm going to place this tag. It says, if you can see the status here, it says formatted. I'm going to write a URI here, say http www.bbc.co.uk/ and to write I'm going to place this tag again. Now we are able to write successfully. So to summarize, what we have learned in this video is we learned how to create a mat format byte by byte, and we also wrote the application IDs, and we also have an ID which is of type which belongs to the administrator group, and we have set that as the card information, the card holder information. So and we also seen how to load the data of a file and write the entire tag. So okay, thanks for watching.